a polynomial, okay? We all know that we can simply evaluate by substituting in the given value for the independent variable, right? So if I tell you x equals 2, you just plug it in and you do all the math, right? However, we can also use synthetic division to evaluate, okay? What this is called is our remainder theorem. Okay, the remainder theorem is if a polynomial, p of x, is divided by a binomial, x minus a, then the remainder obtained is p of a. So the remainder obtained is the value as if you took a and substituted into the polynomial equation. So we're going to look at this completed example. So for example, if I was dividing x cubed minus 4x squared minus 7x plus 10 by x minus 2, and I wanted to know what would the remainder be, I could plug in the 0. So I would have x minus 2, set it equal to 0, get x equals 2. I would plug in the 0 value into the polynomial. So into the polynomial, I would plug in 2. And then I would evaluate just like normal situation. Plug in 2, 2 cubed is 8, plug in 2, 4 times negative 4 is negative 16, plug in 2, get 14, bring down the 10, add, subtract, and I get boom. So this would be the value of my remainder. Because of that, I can use synthetic division to evaluate. And it kind of makes it a little easier because I don't have to have such larger numbers at all times. And it's just an option to evaluating. So for example, looking at this function notation here, we have p of 3. So if I wanted to find p of 3, option number 1 is I can do 3 to the 4th minus 2 times 3 squared minus 3 plus 122, right? And get my answer the old school way. Agreed? If I wanted to find p of 3. Now, using synthetic division, I would put the 3 in the house, list out my coefficients, 1, negative 2, negative 1, 122. And begin the synthetic division process. Bring down my 1. 3 times 1 is 3. Negative 2 plus 3 is 1. 3 times 1 is 3. Negative 1 plus 3 is 3 times 2 is 122 plus 6 is. So the answer would be 128. So p of 3 equals 128. So yes, could you evaluate the traditional way? Go for it. But I wanted to show you that you also can utilize synthetic division because of the remainder theorem to evaluate. Okay, let's try another one. So we have p of negative 4. Again, traditionally, I could plug in for x a negative 4 and evaluate. But we're going to use synthetic division. List out my coefficients, 1, negative 3, negative 28, 5, and 20. Bring down 1. Negative 4 times 1 is negative 4. Negative 3 and negative 4 make negative 7. Negative 4 times negative 7 is 28. Negative 28 and 28 make 0. Negative 4 times 0 is 0. 5 and 0 make 5. Negative 4 times 5 is negative 20. And I get 0. So p of negative 4 equals 0. How do you feel? Still with me? Okay. I'm going to pause and give you a minute to do one on your own. All right, what was the first thing you noticed? It's missing. We're missing our x squared. So when you're evaluating, negative 2 went in the house, and you had 1, 9, 0, negative 9, and 2. We're going to bring down our 1. Negative 2 times 1 is 9 minus 2 is 7. Negative 2 times 7 is negative 14. 0 and negative 14 make negative 14. Negative 2 times negative 14 is positive 28. Negative 9 and 28 make negative 19. Positive 19. Negative 2 times 19 is negative 38. And 2 minus 38 is negative 36. So you know P of negative 2 equals negative 36. Bam. Synthetic division to evaluate using the remainder theorem. Cool? All right.